Hello everyone. Let us see now next example depend on the convolution theorem. We are learning convolution theorem here. Here one is one. This is homework for you. S upon s minus 1 s square plus 4. Denominator is this. Okay. First call it phi 1 as s upon s square plus 4 and other is 1 upon s minus 1 phi 2. Okay. Phi 2 must be a simpler um, fraction or a simpler equation or a simpler term whose inverse Laplace transform is also a simplest equation or simplest function. Okay, this is the simplest one, that's why it must be phi 2 1 upon this. Yes, sure, you should give it to s square plus 4 so that it becomes cos. Okay, and this becomes exponential. Okay, now consider next uh, example, that is denominator this is 1 upon s minus 2 and s plus 2 bracket square is there. Okay, now we have to divide this function into two terms. First consider phi 1 of s is equal to this function 1 upon s plus 2 bracket square, which is quite difficult than this function, that's why I call it as phi 1, and other simpler one that is phi 2. Okay, now we have to calculate the inverse of this function, that is L inverse of phi 1 s is equal to, that is L inverse of this term as it is. Now we have to use this use here first shifting property, that is exponential property, so that s plus 2 is here, and by exponential property we can take this plus 2 outside as e raised to opposite of that minus 2t. L inverse of, just delete this plus 2 from this function, we get 1 upon s square only, rest of the terms as it is. Now what is L inverse of 1 upon s square? That is t raised to 2 minus 1, that is 1 upon 1. That's why answer for this inverse is e raised to 2 minus 2t into t. Call it as f1 of t. Inverse of phi 1 we have to call it as f1 of t. Now let us phi 2 is equal to second function, that is 1 upon s minus 2, and inverse of phi 2 is L inverse of 1 upon s minus 2 is e raised to plus 2t. It is a standard example. I call it as f2t. Inverse of phi 2 is f2. Okay, now use convolution theorem. Therefore write down the statement for this convolution theorem first. By convolution theorem we know L inverse of phi 1 into phi 2, that is multiplication of these two function, is equal to integration 0 to t f1 u f2 t minus u. Okay, now put this all these values in this equation, we get L inverse of phi 1 into phi 2 is our original example, multiplication of factor is equal to integration 0 to t f1 u. F1 u means f1 t replace t by u, here we get e raised to minus 2u into u, this is f1 u, and f2 t minus u means replace t by t minus u in f2, we get e raised to 2 as it is and t replaced by t minus u and du as it is. Now we have to solve this integration with respect to u. Just first simplify this exponential, this as it is, e raised to this multiply this 2 inside the bracket and split this exponential, we get e raised to 2t into e raised to minus 2u. We have four terms, and this e raised to minus 2u, e raised to minus 2u becomes e raised to minus 4u, and in next step e raised to 2t is a constant regarding this integration, because integration is with respect to u, that's why e raised to 2t gets outside from the integration. Therefore integration becomes u into e raised to minus 4u. Now we have to solve this using bipart rule, that is put the bracket first, u into integration of second is e raised to minus 4u upon derivative of minus 4u is minus 4, minus put the brackets minus u derivative is 1 with respect to u is 1, and this terms integration here, that's why e raised to minus 4u integration is e raised to minus 4u upon minus 4, already minus 4 is there, that's why minus 4 into minus 4 plus 16. Next term plus 1 derivative is 0, that's why this process ends here, bipart rule ends here, and limits are 0 to t as it is. Now put the limits t in u first, e raised to minus, take first minus, simplify this term by removing the brackets, take minus outside, we get minus e raised to 2t into bracket u e raised to minus 4u upon 4 plus e raised to minus 4u upon 16. All gets plus because we already take minus outside. Okay. Therefore, minus e raised to minus 2t, take 4 from the denominator, we get inside the bracket u into e raised to minus 4u plus e raised to minus 4u upon 4. This is a more simplified form. Now put the limits first. In u, we have to put upper limit t. We get t into e raised to minus 4t plus e raised to minus 4t upon 4. This is whole upper limit. Now lower limit minus 0 we have to put in u. This becomes 0 and here e raised to 0 is 1 upon 4. This is our lower limit. This is our answer. Now we have to just simplify. Just remove this bracket, we get minus 1 by 4. Rest of the term as it is, and take, this is our answer. Now take minus inside and this 4 outside, we get 1 upon 16 here, and e raised to 2t e raised to minus 4t becomes e raised to, this is a negative term, we take here. Okay, here already 4 get outside, that's why it becomes 4t e raised to minus 2t. This becomes again minus e raised to 4 get outside, e raised to 2t minus 4t becomes e raised to minus 2t, and this becomes plus, that's why it takes first term. We have to take first term as 4 take outside, e raised to 2t as it is. Okay, or you can keep this as it is without taking common. This is the answer for this question. Okay, now consider next example, depend on the convolution theorem. One upon s into s plus 1 s plus 2. Okay, now we have to split this into 2 so that the we can find out the inverse easily. Now you can these are the three terms, you can make any two combination, s into s plus 1 and s plus 2, or s into s plus 2 and s plus 1. Conveniently take phi 1 is equal to the most difficult one, that is product of two term, that is 1 upon s into, take this first two, s plus 1. Okay, and second one 1 upon s plus 2. Okay, this is a splitting of this example. Okay, so that the easiest term will be second, phi 2 is the easiest one. Okay, that's why now we have to take the inverse of both the function. This inverse is very easy. L inverse of phi 2 is L inverse of 1 upon s plus 2, that is e raised to minus 2t. Call it as phi 2 inverse is f2t. Now L inverse of phi 1, with this we have to find out L inverse of s 1 upon s into s plus 1. Okay, now we have to split this denominator by, this is the one method to splitting the denominator, linear denominator easily. That's why suppose 1 upon, this is s plus suppose 4 and s suppose minus 1 is there. Okay, now we have to split this. This method can be used when the functions or the product is brackets are linear only, s raised to power 1 should be there only. Okay, for higher order it is little difficult. That's why whenever in the denominator linear factors are there, you can do this shortcut. Okay, now which one is biggest factor? Obviously this s plus 4 is bigger than s minus 1, that's why keep this at the second term, 1 upon s plus 4, and keep this to the first term. Okay, now middle sign must be minus. Okay, this is the method. What is the method? You just split this fraction by putting the highest term at the second place. S plus 4 is a highest term than s minus 1, that's why we have to put it in the second place, and s minus 1 is the lowest number, that's why, or lowest term, that's why it is placed in the first term, first place. Now we have to subtract this. Now we have to decide which number numerator must be 1, that's why we have to do the cross multiplication. What with the cross multiplication? This is denominator is same, multiplication of these two, we have to just find out the number which is extra to the denominator. Just cross multiply. This is s plus 4 minus s minus minus plus 1. Yes gets cancelled. That's why 4 plus 1 is equal to 5 get extra in the denominator. That's why we have to divide this factor by 1 by 5. Okay, this method you can apply to any term. For example, suppose 1 upon yes minus 1 and yes plus suppose 2. Okay, yes plus 2 is the highest, that's why I put it in the second place. Yes minus 1 is the lowest term, that is put in the, keep that in the first place. Now middle term obviously minus. Okay, now cross multiply, we get s minus 1 into s plus 2 is the denominator as it is. Cross multiply because s plus 2 minus s minus minus plus 1. Okay, yes gets cancelled. 2 plus 1, 3 get extra number in the denominator. We have only 1, that's why we have to divide this factor by 3. This is the splitting of fraction. Okay, this is a one partial fraction only, but it is a shortcut to the linear factors. In this way, for this factor s and s plus 1, these are two linear factors. Okay, which one is biggest? Obviously s plus 1 is the biggest, that's why keep that in the second position. 1 upon s in the first position. Obviously middle one is subtraction. Now cross multiply, denominator is same, s into s plus 1, denominator is same. Cross multiply s plus 1 minus s, this gets cancelled. Numerator is in the numerator 1 is there, and this is correct because already 1 is there, we want 1. That's why this is a splitting of this fraction. Okay, we use that rule here. This one. Okay, this fraction split into 2 by 1 upon s minus 1 upon s plus 1. You can do this for linear factors only. Okay, now take the inverse inside, we get 1 upon s inverse is 1, 1 upon s plus 1 inverse is e raised to minus t. Call it as f1t. Inverse of phi 1 is f1. Okay, now use convolution theorem to find out inverse. This is the statement of convolution theorem. L inverse of phi 1 into phi 2, that is L inverse of our original example, is equal to, this is a formula, integration 0 to t f1 u into f2 t minus u du. Okay, remember here the integration is with respect to u, not t. Now put the values, integration 0 to t f1 u, f1 is this, put t by u here, 1 minus, put the bracket 1 minus e raised to minus u, this is f1 u, and f2 t minus u means replace here t by t minus u, we get e raised to minus 2 t minus u du as it is. Okay, therefore now we have to solve this integration, split this exponential, we get e raised to minus 2t, e raised to minus minus plus 2u. E raised to minus 2t is a constant regarding this integration because integration is with respect to u. It doesn't contain u, that's why take outside as a constant, e raised to minus 2t. Integration as it is 0 to t, this bracket into e raised to 2u. Okay, now take e raised to 2u inside the bracket, we get e raised to 2u minus e raised to 2u into e raised to minus u becomes e raised to plus u. Okay, the base is same, index gets add, we get 2u minus u becomes u du. Now integration with respect to u becomes e raised to 2u, integration is e raised to 2u upon 2, rest of the terms as it is, e raised to u integration is e raised to u. Okay, now we have to put the limits. Upper limit is t, we have to put u e raised to minus 2t outside the term as it is, and upper limit first put t in u, we get e raised to 2t upon 2 minus e raised to 2t, minus lower limit we have to put 0, that's why it becomes 1 by 2 first, here 0, lower limit become here 0, we get 1 by 2 minus here 0, we get e raised to 0 is 1, 1 by 2 minus 1 is the lower limit. Okay, this is half minus 1, This is our answer. Now simplify this terms as it is. Half minus 1 is minus half, minus minus becomes plus half here. Okay, take half outside, we get e raised to half into e raised to minus 2t. Here we have to multiply by 2 only. Okay, the rest of the terms as it is. Now take e raised to minus 2t inside, we get half. This is e raised to minus 2t into plus 2t becomes e raised to 0, that is 1, minus 2 into e raised to minus 2t plus t minus t plus e raised to minus 2t. This is the most simplified answer for our question. Okay. Now these are some homeworks for you. This is a upon s into s minus 1. Answer is this. This is the other homework, s square upon s square plus 4 bracket square. Okay, both the functions are same. Answer is this by convolution theorem only. Okay, these are the example of convolution theorem only. Okay, now consider next property, that is division by s property. Statement is let L inverse of phi of s is equal to f of t. Then L inverse of phi of s upon s. If any function get divided by s, we can use this formula. L inverse of phi of s upon s becomes, it is the integration 0 to t this function f of t dt. What is this function? This numerator's inverse. What is the numerator is? We have to take inverse of this function, call it as f of t, and we have to just solve the integration. Now consider example depend on this property. Find the inverse Laplace transform of the following function. Question is same. Example is 1 upon s into s square plus 4. This example you can solve it by partial fraction also and convolution theorem also. But here you can use division by s property here. If in the example simply they ask for finding the inverse, you can use any method. Okay, now here we are going to see the division by s property. What is division by s? It is in the denominator s should be there. Okay, that's why our original function is this 1 upon s square plus 4. That's why we have to call it as phi of s first. That first step, our first step is we have to call the function in the numerator or the function which is present with multiplication of 1 by s as phi of s. Okay, let phi of s is this function which is apart from 1 upon s, that is 1 upon s square plus 4. Now next step is we have to find the inverse. Therefore inverse of phi of s is, this is sine inverse 1 upon 2, 4 root is 2, sine same angle 2t. Call it as f of t by using this property. Okay, now apply the property. We know this, we have to write the property in each and every example. L inverse of phi of s upon s is integration 0 to t f of t dt. Now put this value everywhere, we get L inverse of phi of s upon s means this division by s is our original example is equal to integration 0 to t f t is half sine 2t dt. Now take half constant outside, sine integration is minus cos 2t and divided by derivative of angle is 2. Limits are 0 to t. Put the limits, we get, take minus outside, 1 by 2 into 1 by 2, 1 by 4. Cos 2t, put upper limit first, t in t only, that's why it is becomes cos 2t only. Minus cos 0, we know cos 0 is 1. Take minus inside, answer is 1 by 4. Reverse the term, 1 minus cos 2t. This is a very simple example. If you apply convolution theorem, if you apply partial fraction method, it becomes lengthy example. That's why you can use this division by s property if in the example they don't ask for any particular method. Okay, now consider next example. One upon s into s plus 1 bracket cube. Okay, our function will be 1 upon s plus 1 bracket cube. Call it as phi of s. Now we have to find the inverse. Therefore L inverse of phi of s is L inverse of 1 upon s plus 1 bracket cube. Of course here we have to use first shifting property. That's why we get e raised to minus 1t get outside, L inverse as it is, and just remove this plus 1, we get 1 upon s cube. This is our first shifting property, we have studied already. And now 1 upon s cube inverse is t raised to 2, that is 3 minus 1 upon 2 factorial. 2 factorial is 2. This is the answer for this inverse. Okay, this function's inverse. Call it as f of t according to our property. Now we know L inverse of this is our property. L inverse of phi of s upon s is equal to integration 0 to t f of t dt. Put this value here, we get L inverse of phi of s. What is our phi of s upon s? Our original example is equal to integration 0 to 2. Put this value f of t here dt. Now we have to solve this integration. Take half outside, it's a constant, and u into v rule we have to apply here. U is t square, v is e raised to minus t. U into integration of v, u as it is integration of e raised to minus t is e raised to minus t upon minus 1. Put the brackets everywhere, minus. Now t square derivative here, 2t. And this integration here, this term's integration is minus 1 is constant, e raised to minus t integration is e raised to minus t upon minus 1. Already minus 1 is there, that's why it becomes plus 1. Put the brackets. Next term plus minus, alternative plus minus, that's why it becomes plus. This term's derivative here, 2t derivative is 2, and this term's integration here e raised to minus t integration is e raised to minus t upon minus 1. Now next term will be minus 2 derivative is 0. That's why this u into v procedure stops here or ends here. And put the brackets, curly bracket and round bracket and square bracket complete here. Integration limits are as it is 0 to t. Okay. Now we have to simplify first before putting the limits. Just remove the all brackets, we get this term here. Minus take into center. This minus as it is 2t into e raised to minus t. This is minus 2 into e raised to minus t. Now put the limits, upper limit t in t only, that's why take a minus outside also. All terms are minus, that's why take outside minus, all terms one plus here. Now put next here limits t in t, that's why this becomes as it is. Okay, now minus lower limit, you have to put 0 in t. This becomes 0, this becomes 0, and this becomes e raised to 0 is 1, only 2. This is our lower limit. Bracket complete. Now next step, just remove this bracket, rest of the terms as it is. This is our answer, final answer for this question. Now consider next example. 1 upon s into root s plus 4. Therefore our question will be, our original function will be phi of s is equal to 1 upon root s plus 4. We have to take inverse. This is very important question because a little difficult it is. Now we have to take inverse on both sides. We get L inverse of 1 upon root s plus 4 becomes, we have to use of course first shifting property. This is first shifting property. You have to write first shifting property, okay? Everywhere. I am not writing here. You have to write in the assignments. Now e raised to plus 4, opposite of that minus 4t take outside, and L inverse as it is, just delete this plus 4 from everywhere. We get 1 upon root s only. This is the first shifting property, which we call it exponential property also. Now s raised to half is there. Inverse of s raised to half is 1 upon t raised to half minus 1 upon gamma. It is a fraction, that's why we have to use gamma formula for 1 upon s raised to n. That is t raised to n minus 1 upon gamma n. What is n? Half here. Okay. Now what is gamma half? It is a root pi. It is a constant. And t raised to half minus 1 is minus half as it is. Okay. Call it as ft. F of t. Inverse of phi of s. Now we know in division by s property, L inverse of phi of s upon s is equal to integration 0 to t f of t dt. Okay, put this value, we get L inverse of phi of s upon s is, this is L inverse of 1 upon s into under root s plus 4 over original example. L inverse of 1 upon s into s root here root s plus 4 is equal to integration as it is. Ft is this, put this as it is here. Okay, dt. Now here we have to solve this integration with respect to t. Now root pi is a constant, take outside. We get 0 to t raised to minus half, e raised to minus 4t. Okay. Here we cannot use u into v rule because t power is minus. Negative power, if arithmetic have negative power, we cannot use this u into v rule because it doesn't get ends anywhere. That's why we have to apply some other method here to find out this integration. This is very important integration. Okay, this is the only example where this integration comes. Okay, now if you observe this, we know one definition of error function of root t. What is error function of root t example? This is a definition. Is equal to 2 upon root pi integration 0 to root t here e raised to minus t square dt. This is the definition of error function of root t. We have to apply this definition, or to use this you can use this definition to solve this integration. For if you observe this integration, okay, here e raised to minus t square is there, and here e raised to minus 4t is there. If you want to use this integration here, this e raised to minus this 4t becomes square of one variable. That's why ultimately we have to put this substitution here. We have to use substitution method here. What we have to put? 4t in terms of square of the variable. That's why substitution is put 4t is equal to x square here in this integration. Okay, this is a substitution which comes from this definition. Okay, to solve this integration. Now simplify, or like integration, we generally do what we do, take derivative on both sides. We get 4 into t derivative dt is equal to x square derivative is 2x dx. Okay, that's why dt is equal to, take 4 on this side, we get x by 2 dx. Okay, this, and we have to check now limit, new limit. Original variable is t and new variable is x. Original old limits are 0 and root t here. Sorry, here original limits are 0 and t. Okay, and the new limits for x are, when x is 0, obviously t is 0. When x is t, okay, x is t, we get when t is t, okay, upper limit for t is t only. If you put t is equal to t, we get x is equal to, take square root on both sides, 2 root t. Okay, these are the limits for the given example. Now put this all this substitution here in this example. What we get? L inverse of this is LHS side is equal to 1 upon 1 by root pi as it is. Lower limit becomes 0, upper limit becomes 2 root t, and e raised to minus x square, it becomes minus x square. Dt becomes here x by 2 dx, and here again t raised to minus half. What is t from here? X square by 4. Okay, and raised to minus half. This is our substitution. Now no integration is with respect to x. We have to solve this. Now simplify this. Take this 2 outside. We get 1 upon 2 root pi. Limits as it is, e raised to minus x square, x dx as it is. Here minus is there in dice. That's why reverse this term. 4 upon x square raised to half. Okay. In the next step, fourth root raised to 1 by 2 means root of this term. Fourth root is 2. Take outside here. Okay, and integration becomes x into e raised to minus x square dx, and 1 by x square's root is x. Now next step, x gets cancelled. We get one upon root pi integration 0 to root 2 root t e raised to minus x square dx. This is our final integration. Now if you observe this integration with the error function of root t here. Okay, if you observe this integration with this integration, if this integration is error function of this root t, 2 upon root pi is there. Okay, that's why this integration becomes, we have to for this 2 upon root pi is already there. For this 2, multiply and divide by 2 here. This is one adjustment, and this as it is, and this is the error function of, this is root t, here 2 root t. Okay, rest of the terms as it is, only upper limit becomes 2 root t here. That's why this is error function of 2 root t. Here upper limit is root t, that's why it is called error function of root t. That's why answer for this integration is error function of 2 root t. This is a standard function. You can write this as it is. Okay, this is the answer for our question. Now consider next, 1 upon s cube is now s square plus s square. We have studied phi of s division by s. We are learning division by s property. Here division by s cube is there, 3 times division by s. That means we have to apply this formula 3 times. Okay, successively on this function. Okay, now start. Let phi of s is equal to this function 1 upon s square plus a square. L inverse of phi of s is 1 upon a, this is sine, 1 upon a sine 80. Call it as f of t. Now first apply this formula, for write down the formula first. L inverse of phi of s upon s is equal to integration 0 to t f of t dt. What is f of t? This function's inverse. Okay, now put the value L inverse of 1 s. We have to divide first 1 s by 1 s. We get 1 upon s into s square plus this function s square is equal to integration. Already 1 by a is a constant, take outside, integration 0 to t sine 80 dt. Solve this integration first. What is sine integration is minus, take outside, cos 80 upon 80 derivative is a, 0 to t. Take a outside, 1 minus 1 upon a square. Put the limit cos 80 t in t, we get cos 80 upper limit minus cos 0 is 1. Okay, now take this minus inside, we get a reverse term 1 by a square, 1 minus cos 80. This is the answer for division by 1 s. Okay, call it as next f of t, that is f1. Already we use f of t, call it as f1 of t. Now apply same formula here for f1, division by second s. We get 1 upon, therefore 1 upon s square now, and original function s square plus a square is integration now f of t replaced by f of f1 of t here. Okay, becomes second integration 0 to t f1 t dt. Put this value f1 t here. 1 upon a square is a constant, take outside, integration 1 minus cos 80 dt. One integration is t, integration of 1 is x, with respect to t is t, minus cos integration is sine 80 upon a. Okay, put the limit 0 to t. Therefore put upper limit t in t, we get t minus sine 80 upon a, minus lower limit 0 in here, it becomes 0, sine 0 is 0, lower limit is 0. That's why answer is 1 upon a square t minus sine 80 upon a. This is second division by s, s square. We want last integration now for s cube. Apply same formula for this function, call it as f2 of t. Therefore we get last division by s. We have to find out third integration, 1 upon s cube, s square plus a square is equal to, replace f of t by now f2 of t. Okay, and this is a formula. Put the f2t here, we get 1 upon a square, take outside, f2t t minus sine 80 upon a dt. Okay, now take integration, t integration is t square by 2, sine 80 integration is minus cos, that's why it becomes minus minus plus cos 80 upon a, already a is there, that's why it becomes a square, limit 0 to t. Okay, now put upper limit in t, where it is t itself, t square by 2 plus cos 80 upon a square, minus lower limit we have to put 0. Here 0, it becomes 0, cos 0 is 1, that's why 1 upon a square is our lower limit. Bracket complete, square bracket complete. Now next, just remove this bracket. Okay, now take this common, cos 80 minus 1 upon a square, and plus this term as it is. This is our answer for this question. Division by s, how many times division by s is there? You have to use that much times the same formula, and you have to integrate those functions only. Okay. Okay, now these are some homeworks, very easy homework for you. Depend on the division by s only, you have to solve these examples. Okay.